Astronomers have just discovered something that truly should not be happening. At this very moment, 7 comets are racing toward the Sun, all scheduled to arrive within mere days of each other in October 2025. Nothing like this has ever been recorded throughout human history. Yet what makes this discovery profoundly unsettling is the timing. 3I Atlas, an object that hails from an entirely different star system, is also making its closest approach during this same extraordinary window. The odds of such a coincidence are astronomically small. So small that it forces us to ask whether something is orchestrating these arrivals. Could this be more than a chance flyby? Could it be the beginning of something far more mysterious, perhaps even sinister? Tonight, here on The Cosmic Dreamer, we are going to investigate every possibility and speculate about forces operating beyond the boundaries of our current scientific understanding. Stay with us until the end to uncover what 3I Atlas is truly doing to our solar system. A sky filled with visitors. That is the spectacle 2025 promises to deliver. In a typical year, we might be fortunate enough to witness 1, perhaps 2 comets worth noting. Most years pass with little more than faint telescopic smudges, objects that stir excitement only among the most devoted comet hunters. But 2025 is different. It is as if the universe has chosen this year to stage a grand parade across our heavens. Allow me to introduce the cast of characters that has astronomers double-checking their calculations. Pan-stars, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and Neat. 7 distinct comets, each carrying ice and rock from the farthest reaches of our solar system, all arriving within months of one another, like some cosmic reunion no one had planned. Think of it like this. Imagine 7 friends from across the country all appearing at your doorstep the very same weekend, each insisting they had no idea the others were coming. Is it possible? Yes. Is it coincidental? Certainly. But is it suspicious enough to make you wonder whether someone secretly sent invitations behind your back? Absolutely. This clustering creates what astronomers refer to as a swarm effect. Multiple comets crowding into a narrow observation window make the sky look as though the arrivals are orchestrated, as though something invisible has gathered them together. Before diving deeper into this celestial mystery, let's establish a few ground rules. When we speak of perihelion, we mean the comet's closest approach to the Sun, the precise moment when solar heating transforms distant chunks of ice into spectacular tails of glowing gas and dust. Closest approach refers to the distance between a comet and Earth, which tells us whether you will need binoculars, a telescope, or only your naked eyes to catch a glimpse. And magnitude measures brightness. The lower the number, the brighter the object. A magnitude of 6 sits right at the threshold of naked eye visibility beneath dark skies, while a magnitude of 0 rivals the brightest stars. The visual evidence is compelling. Imagine a chart of comet arrivals across decades, each appearance marked as a dot scattered randomly like raindrops on pavement. Now, picture the year 2025, 7 dots clustered together, like marbles dropped into the same small circle. The pattern leaps out immediately. Most years, amateur astronomers spend months chasing just one comet worthy of photographing. But in 2025, they are spoiled for choice. Photography forums will hum with images of multiple comet tails streaking across the same patch of sky. Social media will erupt with time-lapse videos that look like a celestial ballet, coordinated, choreographed, almost too perfect. And yet, while these 7 comets perform their predictable orbits, something else prowls the darkness between planets. 3I Atlas, the 3rd confirmed interstellar object ever detected, is unlike the others. Unlike our 7 cometary visitors, this one was not born here. It formed around another star in another planetary system, and now it races through our neighborhood on a hyperbolic path, a one-time visit. The timing raises questions that keep astronomers awake at night. Is it truly coincidence that the solar system's most unusual comet year coincides with the arrival of an interstellar wanderer? Or could there be something more deliberate at play? Throughout this investigation, we will hold to one guiding principle, separating measurable facts from speculation. When we present orbital data, observation logs, and brightness measurements, those numbers can be trusted. But when we wander into territory that stretches beyond confirmed science, we will clearly mark it as speculation. This is not about forcing theories. It is about following the evidence wherever it leads. Our test is straightforward, yet rigorous. If 3i Atlas is somehow connected to this 7-comet swarm, that connection should leave observable signatures, timing correlations that stretch beyond mere probability, orbital patterns that hint at design rather than chance, physical interactions that can be measured and confirmed. We are not seeking vague impressions or subtle hints. We are searching for evidence so concrete it would convince even the most skeptical of astronomers. If these 7 comets truly arrived independently, driven only by the mathematics of orbital mechanics, then we are simply witnessing an astonishing coincidence, remarkable but ultimately natural. The universe, after all, is vast enough to occasionally surprise us with alignments that appear meaningful but are not. But if some external influence, gravitational, electromagnetic, or something altogether unknown, has nudged these objects towards synchronized arrivals, then we may be staring at forces operating on scales we barely comprehend. Forces that could reshape our very understanding of motion through the cosmos. Every comet tells a story. Each orbit is a fingerprint of the forces that guided it across unimaginable spans of time and distance. If something has shepherded these 7 into the same narrow window of 2025, those fingerprints should be visible, waiting to be uncovered. The arrival of 3i Atlas adds yet another layer of intrigue. This interstellar traveler carries ice and dust born in the light of another sun, materials seasoned by millions of years, drifting through the interstellar void, bombarded by radiation, scarred by cosmic rays. Its composition offers clues about the formation of planetary systems elsewhere. Its behavior as it approaches our sun reveals how alien materials respond to familiar heat. But what if its arrival is not random at all? What if the same force that might have herded 7 solar system comets has also delivered this interstellar stranger right into our midst? How would such a force even operate, spanning gulfs of space with such uncanny precision? And if such coordination is possible, what does that reveal about the true nature of our cosmic neighborhood? The swarm has arrived, and with it comes questions. Questions that may challenge everything we think we know about our solar system. But before answers can be sought, we must meet our 7 visitors one by one and understand what makes each of them unique. Coincidence or connection? The evidence is waiting. It is time to begin measuring. Long before astronomy became a science, comets were messengers. They appeared suddenly, blazing across skies unprepared for them, and people could not help but see them as signs. A bright streak of light in a world without telescopes, satellites, or astrophysics was not an event to be explained. It was a story to be interpreted. And so, for millennia, comets belonged as much to culture as to the cosmos. The ancient Chinese were among the most meticulous observers. They called comets broom stars, their long tails imagined as cosmic brushes sweeping across the heavens. Dynastic court records documented their appearances in painstaking detail. When a comet flared, scribes noted its direction, its brightness, its shape. But they didn't stop at description. They recorded the comet's supposed meaning. A broom star pointing toward the emperor's palace might foretell the fall of a dynasty. Another, brighter and sharper, could be read as a warning of war. These interpretations carried weight, shaping decisions of rulers who feared the heavens were writing their fate. In Babylon and Assyria, priests scanned the skies for omens. Comets were woven into their divination systems, placed alongside eclipses and planetary alignments as voices of the gods. When a bright visitor appeared, they linked it to famine, to plague, to conquest. Their tablets carried these warnings forward in time, embedding fear of comets deep into cultural memory. Europe inherited that dread. In medieval chronicles, comets almost always signified catastrophe. The Bayeux Tapestry, depicting the Norman conquest of England in 1066, famously includes Halley's Comet hanging ominously in the sky as Harold Godwinson prepares for battle. To those who witnessed it, the connection was obvious. A star had fallen, and with it, a king's fortune. The comet became part of the legend, stitched in thread as proof that the heavens had foreshadowed the fall of Saxon rule. Centuries later, in 1456, Halley's Comet returned. This time, it was linked to the Ottoman Empire's advance into Europe. Pope Calixtus III even issued prayers against what he called the Comet of Terror, as if divine intercession could shield Christendom from both celestial and earthly invaders. Again, a natural object was transformed into a supernatural omen. Even as the Renaissance dawned and science began to loosen superstition's grip, comets retained their aura of mystery. In 1577, the great Danish astronomer Tycho Brahe carefully measured a comet's parallax and proved that it must lie beyond the moon, shattering the Aristotelian belief that comets were merely atmospheric phenomena. His data placed comets firmly in the realm of celestial mechanics, yet for ordinary people, they remained portents, too bright and too sudden to be seen as anything but warnings. By the Enlightenment, thinkers like Edmund Halley transformed comets from omens into predictable objects. Halley recognized that the bright visitor of 1682 was the same as those seen in 1531 and 1607. With Newton's laws of gravity as his guide, he calculated its return, confidently predicting it would reappear in 1758. When it did, right on schedule, a comet became not a divine message but a scientific triumph. Halley's comet shifted from prophecy to proof. The heavens followed laws, not whims. And yet fear did not entirely vanish. In 1910, Halley's return coincided with a new tool, the spectroscope. Scientists announced that its tail contained cyanogen, a toxic gas. Newspapers exaggerated the news, sparking panic. Some believed the Earth would pass through the tail, poisoning the atmosphere. Entrepreneurs sold comet pills and gas masks to frighten citizens. The comet that once symbolized war and famine now embodied modern anxieties about science and technology. Across cultures and centuries, one theme is constant. Comets command attention. They are too bright, too sudden, too strange to be ignored. Whether as broom stars sweeping away dynasties, heralds of conquest, warnings of plague, or proof of Newton's physics, they have always forced humanity to look up in wonder. This is why the swarm of 2025 matters so deeply. It is not just an astronomical event. It is the continuation of a dialogue that stretches back to our earliest ancestors. When 7 comets gather at once, when an interstellar stranger joins them, we are not only witnessing a physical alignment, we are participating in a cultural inheritance. We cannot help but ask the same questions asked by emperors, priests, and peasants long ago. Why now? Why us? What does it mean? The difference is that we now hold tools they did not. We can calculate orbits with precision Tycho would envy. We can capture spectra Halley could only dream of. We can share images instantly across a planet that once trembled in fragmented fear. And yet, even with all this, the wonder remains. The comets are still beautiful. They are still mysterious. They still stir stories in us, even if those stories now wear the clothing of science. Perhaps that is their true role, not to predict events, but to provoke reflection. They arrive unannounced, refusing to fit neatly into our schedules. They remind us that the sky is alive, that the universe is vast, that our knowledge is still incomplete. They remind us that we are part of something larger, something that humbles kings and inspires children alike. And so, as we prepare to meet the 7 comets of 2025, we do so not only as scientists, but as heirs to millennia of wonder. Each comet carries with it echoes of history, whispers of myths, and the fingerprints of physics. To watch them is to watch ourselves, our fears, our hopes, our progress, reflected in icy fragments racing toward the sun. If one comet is enough to stir excitement, what then of 7? The year 2025 promises not just a rare visitor, but a gathering, a cluster that astronomers have already begun to call a swarm. Their names may sound clinical, like entries in a catalog, but each carries its own story, its own orbit, its own promise of beauty. Together, they form an ensemble unlike anything recorded in living memory. Pan-stars, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and Neat. 7 names, 7 icy travelers, each making its way inward after eons in the darkness. If the night sky were a stage, they are the actors who, by coincidence or design, step into the spotlight at the same time. Their entrances are staggered, but their performance overlaps, creating a season of brilliance no observer can ignore. To understand why this is so extraordinary, one must first remember how rare it is to see even a single comet with the naked eye. Most comets remain faint, requiring telescopes to reveal them as pale smudges against the stars. A year with one naked eye comet is already cause for excitement. 2 is remarkable. 7 approaches the unbelievable. This is why astronomers checked their calculations again and again. They knew the numbers were correct, the orbits had been observed, the magnitudes predicted. But still, the clustering seemed uncanny. The comets had been discovered in different years, by different surveys, using different instruments. There was no single explanation for their convergence, and yet here they were, destined to share the same sky. The visual effect will be profound. Imagine stepping outside on a dark night in spring 2025. Above you, not one streak of light, but several. Some faint, some bright, some with tails that stretch across constellations. Photographers will capture multiple comets in a single frame, their glowing arcs weaving together like a celestial tapestry. The sky will appear alive, crowded with visitors, as though the universe itself had orchestrated a grand display. Pan-STARRS is expected to be the most visible of the group, potentially reaching naked-eye brightness for weeks. SWAN, discovered through its hydrogen glow, will bring a unique spectral signature. Stereo may graze perilously close to the sun, risking fragmentation in a blaze of drama. Atlas K1 and Atlas G3, siblings from the same survey, remind us of the power of technology to reveal hidden travelers. Lemon, steady and modest, holds its place in the middle of the procession, and Neat, the veteran, arrives as if to underline the pattern, long predicted, yet timed to join the others in this extraordinary year. Each has its own tale, but together they form something greater. Astronomers call it the swarm effect, a clustering so striking that it demands attention, even if coincidence is the only cause. In graphs and charts, their perihelia line up like notes in a chord, resonant and harmonious. In the sky, they will paint that chord in light, a cosmic chorus sung across the heavens. For professionals, this is a scientific opportunity. The simultaneous presence of so many comets allows comparative studies rarely possible. How do different compositions respond to the same solar activity? How do their tails behave under identical conditions of wind and radiation? Observers can track not just one case, but 7, building a dataset that will enrich cometary science for decades. For the public, the swarm is an invitation to wonder. No equations are needed, no instruments required. To step outside and see multiple comets at once is to feel the cosmos pressing close, reminding us of its dynamism. It is a reminder that the sky is not static, not unchanging, but alive with motion and mystery. And then, of course, there is the 8th player, 3i Atlas, the interstellar stranger. It does not belong to the swarm in origin, but it shares their stage in time. Its hyperbolic arc, alien chemistry, and fleeting presence make it stand apart, yet its timing ties it inextricably to the story. The swarm is extraordinary on its own, but with the stranger alongside, the spectacle becomes something historic. Skeptics will point to coincidence, and perhaps they are right. Statistically improbable things do happen, but for those who look for patterns, the alignment is irresistible. 7 comets, each born in different cradles of our solar system, arriving at once, one from beyond the stars joining them. Together they force us to ask the oldest of human questions. Is this chance or is it meaning? For now, all we can say is that the sky will be crowded. The year 2025 will not pass quietly. It will blaze with tails of dust and gas, with fragments of ice illuminated by the sun. Astronomers will measure. Photographers will capture. Children will look up and remember. The swarm has been announced. The actors are entering the stage. And soon, the curtain will rise on a performance unlike anything the modern world has seen. Of the 7 comets destined to light up 2025, one already stands apart in both promise and potential. Pan-STARRS. Its name comes from the powerful Panoramic Survey Telescope and Rapid Response System in Hawaii, a set of wide-field telescopes designed not for beauty but for vigilance, watching the sky constantly, cataloging asteroids, tracking near-Earth objects, and yes, occasionally stumbling upon a comet destined for fame. Pan-STARRS is not the first comet to bear this label. The survey has discovered dozens, each carrying the same family name. But this Pan-STARRS is special. Its orbit, brightness predictions, and timing suggest it may become the brightest of the 2025 swarm, a genuine naked-eye spectacle visible to millions. Where other comets may remain faint, requiring instruments or dark skies, Pan-STARRS offers the hope of being obvious, undeniable even in suburban skies, unmistakable against the stars. Predictions in cometary astronomy are notoriously uncertain. A nucleus only a few kilometers wide can harbor hidden reserves of ice or be coated in dark dust that hides its potential. A small outburst, a sudden fragmentation, or the exposure of fresh ice can transform a modest smudge into a beacon. Astronomers estimate pan-stars could reach magnitude 2, perhaps brighter. That would place it alongside the stars of the Big Dipper, visible even to casual stargazers. If outbursts occur, it could surge brighter still, rivaling Venus at its peak, a comet of the kind that makes headlines. Its orbit carries it into favorable skies, accessible from both hemispheres at different points of its journey. This is critical. Comets are democratic in their wonder only when people across the globe can share in them. A northern spectacle missed by the southern hemisphere, or vice versa, divides the audience. Pan-stars, by contrast, seems ready to offer its beauty to the world. But brightness alone does not make a comet memorable. It is the tail, the luminous veil of gas and dust, that transforms a dot of light into a celestial painting. Pan-stars has the potential to grow a tail stretching for degrees across the sky, long enough to cross constellations. Under dark conditions, observers may see it arching faintly over the horizon, a reminder that comets are not stars at all, but dynamic travelers, shedding material as they race through sunlight. For astronomers, pan-stars will be a laboratory. Its activity can be measured night by night, its jets mapped, its dust grains analyzed by spectroscopy. Amateurs, too, will contribute. Equipped with digital cameras and persistence, they will document its evolution, creating a collective record of its passage. Comet science has always been a field where professionals and enthusiasts collaborate, and in 2025, pan-stars may become their shared obsession. For the public, however, the comet will mean something simpler, a chance to look up and be astonished. Most people alive today have never seen a truly bright comet. Halley's 1986 return was disappointing. Comet Hale-Bopp in 1997 dazzled, but that was more than a generation ago. Since then, comets have come and gone with little fanfare, faint streaks for dedicated observers, but invisible to most. Pan-stars could change that. It could be the comet that reminds millions why our ancestors once feared and worshipped these visitors. But comets are fickle. For every spectacular success, there is a disappointment. Astronomers still remember Comet Ison in 2013, hyped as the comet of the century before it disintegrated into nothing at perihelion. Predictions must therefore be made with humility. Pan-stars may blaze gloriously, or it may falter. Either way, its role in the 2025 swarm ensures it will not be forgotten. Its timing places it near the front of the procession, one of the first comets to capture public imagination. This matters. A bright early arrival primes the world to watch for the others, creating momentum and expectation. If Pan-stars dazzles, Swan, Stereo, and the rest will benefit from the spotlight it creates. If it disappoints, anticipation may dim. The burden of being the bright contender is heavy. In mythic terms, Pan-stars becomes the herald, the comet that announces the swarm. Its presence ensures the story begins not with speculation, but with spectacle. It will not only be a subject for astronomers, but for news anchors, photographers, and ordinary families stepping outside after dinner to see what all the excitement is about. And in that moment, the comet's true importance is revealed. Beyond science, beyond data, comets remind us of the simple act of looking up. They connect us to every generation before, to every human who ever wondered at a streak of light across the night. Pan-stars, whether it fulfills or disappoints, will play that role in 2025. It will be the face of the swarm, the bright contender that draws our eyes and begins the story. If Pan-stars is the bright contender, then Swan is the mysterious counterpart, defined less by its appearance to the naked eye than by the way it reveals itself through chemistry. Unlike most comets, Swan was not discovered by a telescope scanning for faint dots of light against star fields. It was found through hydrogen, glowing invisibly in ultraviolet, detected by the Solar Wind Anisotropies Swan instrument aboard the SOHO spacecraft. This is what makes Swan unique. While other comets emerge gradually as survey cameras sweep the heavens, Swan appeared as a sudden hydrogen cloud in data. The Swan instrument was designed not for comets, but to map the flow of hydrogen streaming from the sun, part of the solar wind's vast system of interactions. Yet in its maps, comets sometimes betray themselves, giant hydrogen comets expanding around their nuclei, so large they dwarf the Earth many times over. Imagine a comet not just as a streak of light with a tail, but as an invisible sphere of hydrogen thousands of kilometers wide, glowing in ultraviolet wavelengths that human eyes cannot see. Swan is one of those. Its very discovery tells us it is unusually active, releasing vast quantities of water vapor that, broken apart by solar radiation, produce hydrogen envelopes so immense they register on an instrument built to study the sun itself. For astronomers, this is both a gift and a puzzle. A comet that reveals itself so strongly in hydrogen promises exciting science, a chance to study water production rates, volatile content, and the dynamics of a coma at scales rarely observed. But it also raises questions. Why is Swan so active at such distances? What buried ices are fueling its early display? And what will happen as it draws closer to the sun when heat intensifies the sublimation? Visually, Swan may not rival Pan-stars in brightness. Its glory lies in what lies beyond sight. Yet, under the right conditions, it could still grow a visible tail, glowing faintly green with the characteristic emission of diatomic carbon. If it brightens sufficiently, binoculars may reveal its form, and under dark skies, the naked eye may glimpse its arc. But even if it remains modest to casual observers, Swan will be a star in the data, a comet that speaks in hydrogen more than in light. The symbolism of its name feels almost poetic. Swan, the constellation Cygnus, is a bird crossing the Milky Way in myth and in stars. This comet, discovered through hydrogen, takes on that imagery, a swan whose wings are invisible, beating silently through ultraviolet light. For scientists, it becomes a reminder that beauty often lies beyond what we can see. In the context of the 2025 swarm, Swan plays a special role. It is not the brightest nor the boldest, but it expands the story into other wavelengths. While Pan-stars captures eyes, Swan captures instruments, showing us that the spectacle of the swarm is not limited to visible light. It is multi-layered, multispectral, a performance staged across the entire electromagnetic spectrum. Its hydrogen coma also makes it unusually vulnerable to solar activity. During solar maximum, ultraviolet flux is higher, ionization more intense. Swan's envelope may expand dramatically, flicker, or even fragment under the pressure. For observers, this means it could change rapidly, displaying unpredictable behavior. A hydrogen comet in a stormy solar year is like a delicate instrument exposed to roaring winds. It may sing or it may shatter. The unpredictability is part of its allure. Some comets play by expectations, their brightness curves following models with clockwork precision. Swan does not. It is the wild card, the comet that may surge unexpectedly or fade without warning. For astronomers, this makes it both frustrating and irresistible. Every night of data matters, every spectrum a clue. In cultural terms, Swan reminds us that not all wonders are visible. Humanity is conditioned to seek spectacle, to crave brightness and drama. But Swan whispers a different lesson, that some of the most extraordinary phenomena are hidden, waiting for instruments to reveal them. Its hydrogen glow cannot be seen with human eyes, but it tells a story no less grand, a story of water ice, of solar radiation, of invisible envelopes stretching across space. Together with Pan-stars, Swan begins to sketch the diversity of the swarm. One promises brilliance in visible light, a show for the public. The other offers mystery in invisible wavelengths, a show for science. Side by side, they illustrate the dual nature of astronomy, the pursuit of beauty and the pursuit of knowledge, each enriching the other. As 2025 unfolds, Swan may never dominate headlines. Its light may never rival Venus. Its tail may never sweep across entire constellations. But for those who follow closely, for those who understand what its hydrogen signature means, Swan will be unforgettable. It will remind us that the universe is layered, that what we see is only part of the truth, and that sometimes the most important messages are whispered, not shouted. And perhaps that is Swan's role in the story of the swarm, not to dazzle, but to deepen, not to command attention, but to expand understanding. In a sky filled with visitors, Swan speaks quietly, but with meaning as profound as any of its brighter companions. Among the 7 members of the 2025 swarm, few carry a fate as dramatic as Stereo. Its very name evokes the spacecraft that first glimpsed it, the Solar Terrestrial Relations Observatory. But its destiny lies not in careful study from afar. It is a sundiver, a comet whose orbit plunges fatally close to the solar furnace. If Pan-STARRS is the bright contender and Swan the hydrogen whisperer, then Stereo is the daredevil, the comet that will not survive its own performance. Sun-diving comets are not uncommon in history, but each one captures attention for the sheer spectacle of its doom. As they approach perihelion, the searing heat strips away layers of ice and dust. Tails flare, comets expand, jets erupt. For a few dazzling hours or days, they blaze brighter than anyone expected. And then, just as suddenly, they vanish, destroyed by the very star that made them shine. Stereo belongs to this lineage. Its orbit carries it directly toward the sun, grazing closer than Mercury's path. Astronomers predict it will disintegrate, its nucleus torn apart by thermal stress and tidal forces. To the casual eye, this may seem tragic, a comet with no return, no chance to retreat to the cold sanctuaries of the Oort cloud. But to science, it is an opportunity. Watching a comet die reveals its inner secrets, the strength of its nucleus, the depth of its volatile reserves, the fragility of its structure. In 2011, Comet Lovejoy, another sun diver, astonished observers by surviving a close brush with the solar corona. For days afterward, its tail arced magnificently across the southern hemisphere's skies. Stereo may not be so lucky, but the comparison raises hope. Could it too endure long enough to give us a spectacle? Or will it burn out in a silent puff, recorded only by solar observatories? The timing is especially dramatic. Stereo approaches during solar maximum, when the sun's activity is at its peak. Coronal mass ejections, solar flares, and turbulent magnetic fields will surround its passage. For a comet already on the edge of destruction, this adds a layer of chaos. A tail whipped by solar storms, a nucleus buffeted by sudden blasts of radiation. The result may be a display as unpredictable as it is short-lived. For professional astronomers, the instruments watching the sun, SOHO, Stereo itself, the Solar Dynamics Observatory, will capture the event in exquisite detail. These spacecraft are designed to monitor solar outbursts, but in doing so, they frequently record comets as they dive into the corona. Images of Stereo may show its last moments, its brightness flaring, its tail torn apart, its body evaporating into nothingness. For the public, the challenge will be visibility. Sun divers are often brightest when perilously close to the solar glare, making them difficult or dangerous to observe from Earth. Photographs from space-based observatories may be the best record of its fate. Still, the knowledge that a comet is hurling itself into the sun will capture imagination. The idea of a cosmic traveler choosing a path that ends in fiery destruction resonates deeply, echoing myths of sacrifice and transcendence. Culturally, Stereo reminds us of Icarus, the figure from Greek mythology who flew too close to the sun on wings of wax and feathers. Like Icarus, Stereo's brilliance may come at the cost of survival, yet its story is not one of folly, but of inevitability. Its orbit was carved long ago, dictated by the gravity of planets and the random nudges of time. It does not choose to dive, it is compelled, and in that compulsion lies beauty. The presence of a sun diver within the 2025 swarm adds contrast. While Pan-STARRS and Swan sweep across the night sky for weeks, Stereo will blaze briefly, then vanish forever. It reminds us that comets are not eternal, that many perish unseen, their material scattered into interplanetary dust. The swarm is not just a story of arrivals, it is also a story of endings. Speculation lingers, of course. Could the sun-diving fate of Stereo be part of the pattern? Could its destruction somehow echo in the behavior of the other comets, or even 3I Atlas, the interstellar stranger? The rational answer is no. Its death is an isolated event dictated by its orbit alone. But in a year already filled with coincidence, imaginations will not let the question rest. Whatever its deeper meaning, Stereo's role is clear. It is the sacrifice, the comet whose brilliance is born of its doom. For scientists, it will provide data. For dreamers, it will provide metaphor. And for all of us, it will provide a reminder that beauty often burns brightest at the edge of destruction. The swarm of 2025 is a chorus of voices, each with its own tone. Pan-STARRS sings in brightness, Swan whispers in hydrogen, and Stereo cries out in fire. Together they shape a symphony of cometary wonder. And in that symphony, Stereo plays the tragic note, the suicide diver, the comet that dies so that its story may be told. Every great story contains its moments of anticipation, hopes that rise, only to be tempered by reality. Within the swarm of 2025, Atlas K1 carries that role. When first discovered, its orbit and early brightness suggested it might become one of the year's showpieces, a comet bright enough to dominate headlines and capture imaginations. Yet, as data accumulated, expectations shifted. What once looked like a rising star began to settle into the more modest category of faint visitor. Atlas K1 became a reminder of the fickleness of comets and the delicate balance between promise and letdown. Atlas K1 takes its name from the Asteroid Terrestrial Impact Last Alert System, a network of robotic telescopes scanning the skies for hazardous objects. Like Pan-STARRS, Atlas has become one of the modern world's comet factories, sweeping up discoveries with efficiency that rivals chance itself. Atlas K1 is not the first comet to bear the designation, and it will not be the last. But its role in 2025 is unique. A comet once thought destined for brilliance, now consigned to quieter recognition. The cycle of hope and disappointment is familiar in cometary science. Early estimates of brightness are notoriously uncertain. A comet discovered far from the sun can flare impressively at first, its activity driven by fresh, volatile ices. Extrapolated forward, these early surges predict dazzling displays at perihelion. But as weeks pass, the activity may plateau, revealing a nucleus smaller or less volatile than expected. Atlas K1 followed this path. What looked like the makings of a naked-eye spectacle diminished steadily, until predictions settled on magnitudes too faint for casual observers. And yet to dismiss Atlas K1 as irrelevant would be a mistake. Its presence in the swarm matters, not because of spectacle, but because of timing. It will reach perihelion within the same narrow window as its brighter companions, adding to the chorus of arrivals. For scientists, this is invaluable. Even faint comets contribute data, measurements of gas composition, dust production, orbital refinement. A single comet may tell one story, but a swarm tells seven, each adding contrast and comparison. Atlas K1's modesty sharpens the brilliance of Pan-STARRS and Swan by juxtaposition. There is also poetry in its diminished promise. Comets are the wild cards of the solar system. No other class of object defies prediction so completely. Asteroids move with clockwork regularity, their brightness steady, their surfaces inert. Comets, by contrast, are alive. They flare, they fragment, they fade. They burn brightly only to vanish, or approach invisibly only to explode into sudden splendor. Atlas K1 embodies this unpredictability. It teaches humility, reminding astronomers and enthusiasts alike that the sky does not perform on demand. Its faintness does not erase its beauty. Through telescopes, Atlas K1 will reveal a delicate coma, a slender tail, a greenish hue from diatomic carbon emissions. Astrophotographers will capture it against starfields, recording images invisible to the naked eye. In those images lies quiet artistry, a comet not blazing like Venus, but whispering softly in the language of light. For those willing to seek it, Atlas K1 will reward patience. In cultural terms, Atlas K1 mirrors the human experience of expectation and reality. How often do we anticipate greatness, only to find modesty instead? How often do we imagine grandeur, only to be taught the subtler value of quiet presence? The comet becomes a metaphor for the ways life tempers our hopes, teaching us resilience, patience, and appreciation for what is, rather than what might have been. Within the grand spectacle of the 2025 swarm, Atlas K1 plays the role of humility. Pan-STARRS may dazzle, Swan may intrigue, Stereo may perish in glory, but Atlas K1 reminds us that not every visitor must dominate the stage. Some arrive simply to take their place, to add depth to the ensemble, to prove that even faint light contributes to the whole. Speculation, of course, cannot resist attaching meaning to its story. Was Atlas K1's diminished promise part of the pattern? Did its fading serve some unseen coordination with the others? Rationally, the answer is no. Its faintness is the natural result of a small, less volatile nucleus. But in a year of coincidences, some will see significance even in disappointment. For science, the letdown is still valuable. Each observation of Atlas K1 enriches our understanding of cometary diversity. Why do some comets flare dramatically, while others remain subdued? How do size, composition, and history dictate behavior? By comparing Atlas K1 with its brighter companions, astronomers can begin to answer those questions. The contrast is not a failure. It is a data set. And for dreamers, there is a different lesson. Not all wonders are spectacular. Some are subtle, quiet, easy to overlook. Atlas K1 asks us to slow down, to seek beauty in the faint, to remember that even modest comets carry stories of origins billions of years old. They are fragments of the early solar system, icy time capsules carrying clues from an age before Earth itself had formed. To gaze upon Atlas K1, however faint, is to peer into that deep past. The promise of Atlas K1 may have dimmed, but its place in the swarm is secure. It is the quiet one, the comet that reminds us not every arrival must dazzle to matter. Its story is one of tempered expectations, of promise and letdown, of modesty among brilliance. And in that, it plays its part perfectly. One more voice in the chorus of 2025, one more reminder that the cosmos speaks in many tones, not all of them loud. If Atlas K1 embodies the lesson of tempered expectations, then Atlas G3 is its quieter sibling, a comet discovered by the same vigilant network of telescopes, the Atlas Survey, whose eyes never sleep. Unlike the heroic narratives of bright contenders or doomed sundivers, Atlas G3 enters the story of 2025 as a modest presence, a comet born of systematic watching rather than sudden spectacle. Yet in its quietness lies significance, because it represents the transformation of how humanity encounters the cosmos. ATLAS, the Asteroid Terrestrial Impact Last Alert System, was designed not with comets in mind, but with defense. Its mission is planetary protection, to scan the skies night after night, identifying objects that might one day strike Earth. With wide fields of view and sensitive detectors, it catalogs countless moving points of light, most of them asteroids drifting harmlessly past. But in its vigilance, it also uncovers comets, fragments of ice and dust that, while not threats, become gifts. Atlas G3 is one such gift, a child of the survey's mechanical gaze. For astronomers of past centuries, comets were serendipitous discoveries. An observer scanning the sky by eye might notice a new smudge near a familiar constellation, and news would spread slowly through letters and journals. Each comet felt like a singular marvel, found by chance, carrying the aura of surprise. Atlas G3 breaks that tradition. It is not discovered by chance, but by design. It is a product of automation, a reminder that the frontier of discovery now belongs as much to machines as to human eyes. This does not diminish its wonder. Atlas G3 is still a fragment of the early solar system, a frozen capsule of ancient ices stirred into motion after millions of years in darkness. Its orbit, though less dramatic than that of Pan-STARRS or Stereo, still carries it sunward in the same year as its 6 companions. Its presence in the swarm contributes to the improbable chorus, filling out the pattern that makes 2025 Interstellar remarkable. Predictions suggest Atlas G3 will not reach naked-eye visibility. It may linger around magnitude 10 or fainter, visible only through telescopes and long-exposure photography. For the general public, it will likely remain unknown. But for dedicated observers, its faint glow will be no less meaningful. Through CCD cameras, astrophotographers will record its delicate tail, its coma expanding gently, its color hinting at the chemistry within. Every pixel of those images carries history billions of years old. In this way, Atlas G3 represents the quiet majority of comets. For every Hale-Bopp or Halley that blazes across headlines, dozens of fainter cousins slip past, studied only by specialists and enthusiasts. They are not less important, only less visible. They remind us that the universe is filled not only with spectacle, but with subtleties. Atlas G3's contribution to the swarm is to remind us of that balance. Culturally, Atlas G3 offers a metaphor for the age we live in. It is a discovery born not of human romance, but of systematic vigilance. We no longer rely on shepherds in fields or monks in observatories to spot comets by chance. We rely on algorithms, cameras, and global networks. And yet, once the data is in, once the orbit is calculated, the meaning remains the same. A faint smudge on a screen becomes a comet in the sky, a story to be told, a reminder of origins and scale. Its role in the swarm also has scientific weight. With multiple comets active at once, comparative studies become possible. Even faint members like Atlas G3 provide data on dust production, gas ratios, and tail structure. Together, these measurements allow astronomers to compare comets not just individually, but collectively, building models of cometary families and histories. Atlas G3 may not dazzle the eye, but it will enrich the dataset that makes the swarm scientifically priceless. Speculation surrounds it too, though in softer tones. If the 2025 swarm feels orchestrated, then even the faintest participant becomes part of the mystery. Why, some will ask, should such a modest comet arrive at the same time as 6 brighter peers and an interstellar stranger? Is coincidence enough to explain it? Rationally, yes. The statistics of discovery have improved, and Atlas ensures we see more than ever before. But emotionally, Atlas G3 still feels like part of something larger, drawn into a pattern that defies easy dismissal. In the tapestry of 2025, Atlas G3 is not the brightest thread, nor the most dramatic. But tapestries are not woven of highlights alone. They require texture, background, the subtle tones that allow brighter colors to shine. Without Atlas G3, the swarm would be 6 comets and a stranger. With it, the swarm becomes 7. A sacred number in cultures across history, a number that carries weight even when chance is its only cause. And so, Atlas G3 takes its place. A faint light, born of vigilance, framed by technology, elevated by timing. For those who seek it, it will be there, a whisper of the early solar system, a reminder that discovery today is both systematic and wondrous. The survey's child will not dominate the story, but it will complete it. Not every comet in the 2025 swarm demands headlines. Some arrive not as showstoppers, but as steady companions, filling out the pattern, reminding us that not all cosmic wonders need to blaze at center stage to carry meaning. Among the 7, 2 comets embody this supporting role, Lemon and Neat. One is a relatively new discovery, a mid-tier performer without the drama of pan-stars or the fragility of stereo. The other is a veteran, a comet known for decades, whose predicted return makes it both expected and oddly poignant. Together, they form the connective tissue of the swarm, one in the middle, one carrying the legacy of time. Let us begin with Lemon. Officially named after the Mount Lemmon Observatory in Arizona, where countless faint comets have been discovered. It is part of a quiet lineage of objects identified by dedicated sky surveying surveys. Comet Lemon is not expected to reach naked-eye brilliance. Its brightness will likely linger at the threshold where only binoculars or telescopes can reveal its coma and delicate tail. Yet its timing places it squarely within the crowded window of 2025, ensuring that even if modest, it adds its voice to the chorus. In many ways, Lemon represents the average comet, an icy fragment from the outer solar system stirred sunward by gravity's slow hand. It does not promise spectacle, but science. Astronomers will measure its composition, compare its dust and gas emissions to those of its peers, and add one more data point to the growing mosaic of cometary diversity. For those who seek it, astrophotographers will capture faint streaks of green or blue against starfields, images that may never appear in newspapers but will matter deeply to those who took them. Its cultural role is subtle but meaningful. In a year when multiple comets arrive together, Lemon reminds us of balance. Not every participant in the swarm must dazzle. Some exist to anchor the story, to prove that the extraordinary does not erase the ordinary, but elevates it. Lemon is the reminder that the universe is filled with countless quiet travelers, most unseen, most uncelebrated. In 2025, one of them happens to be visible, reminding us that the sky holds wonders at every scale. If Lemon is the middle child, Neat is the elder. Its name comes from the Near-Earth Asteroid Tracking Program, an ambitious project of the late 20th and early 21st centuries that scanned the skies for asteroids and, along the way, discovered many comets. Neat is not new. Its orbit has been tracked for decades. Its return in 2025 was predicted long before the swarm was recognized. In some ways, it is the most ordinary of the group, a comet doing exactly what orbital mechanics foretold. And yet in the context of the swarm, Neat becomes something more. It is the anchor, the proof that not every member of the 2025 parade is a sudden discovery. Neat was expected, scheduled, inevitable. Its presence underscores the contrast, a known comet arriving alongside 6 others that seem to crowd into the year by coincidence. In this way, Neat represents legacy, the thread of continuity connecting the present swarm to the long tradition of cometary returns recorded by astronomers across centuries. Visually, NEAT is not predicted to dazzle. Like Lemon, it may remain faint, its tail visible only in long-exposure photographs. But even faint comets carry poetry. They remind us that the sky is not always a spectacle for the masses. Sometimes it is a quiet performance for the few who care to watch closely. And in those moments, faint comets can be more personal, more intimate. They are the wonders you must seek deliberately, the treasures hidden just beyond casual sight. Together, Lemon and NEAT round out the swarm, balancing brilliance with modesty, novelty with tradition. They are not pan-stars, drawing naked-eye crowds. They are not stereo, doomed to fiery death. They are not Swan, whispering in ultraviolet, or Atlas K1, fading from promise. They are simply themselves, steady, reliable, present. Their role is to remind us that the story of 2025 is not just about spectacle, but about the totality of presence. 7 comets, each with its place, none replaceable. Scientifically, they enrich the comparison. Bright comets often dominate attention, but faint ones are equally important. Measuring Lemon's gas output alongside NEAT's provides baselines. Observing their tails under the same solar conditions as Pan-stars or Swan allows contrasts that sharpen conclusions. The swarm is not just a coincidence of timing, it is a laboratory and every participant matters. Culturally, their lesson is humility. Comets like Lemon and NEAT will not trend on social media, will not fill newspapers with photographs. But they will still be there. Their icy cores sublimating in the sun, their tails arching faintly in the dark. They embody the truth that not all beauty is obvious, not all wonder is dramatic. Some is quiet, waiting patiently for those who choose to see. In the grand narrative of 2025, Lemon and NEAT remind us of endurance. Lemon, modest and middle, tells us that even the ordinary can be extraordinary when placed in the right context. NEAT, returning after decades, ties us to history, proving that not all surprises are unannounced. Together, they anchor the swarm in both the present and the past, ensuring that the story is not only about brightness and drama, but about continuity and depth. When the history of this year is written, Pan-stars may receive the glory, Stereo the drama, Three-Eye Atlas the mystery, but Lemon and NEAT will be there too, their roles quieter but no less real. They will have orbited, sublimated, shone faintly, and departed, just as countless comets before them. And in that quietness lies their gift, a reminder that the universe is not only spectacle, but persistence, not only brilliance, but endurance. By now, we have met the 7 members of the 2025 swarm. Pan-stars, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and China and NEAT. Each has its own character, its own quirks, its own destiny. Taken alone, none of them would be remarkable. A bright comet every few years is within the range of expectation. A faint 1 or 2 slipping past unnoticed is almost routine. But taken together, something begins to feel different. The sheer number, the clustering, the presence of an interstellar stranger, these combine into a story that forces us to pause. Because this is not normal. Comets are not scheduled like eclipses or planetary transits. They arrive unpredictably, often discovered only months before their closest approach. Their brightness is fickle, their behavior uncertain. A typical year might bring 1 naked-eye comet if we are lucky, or none at all. Most years, amateur astronomers are content to track faint smudges in telescopes, the kind of objects that never make the news. To have 7 comets in a single year is extraordinary. To have them clustered within weeks of each other is unprecedented. Historical records confirm this rarity. The year 1910 brought both Halley's Comet and the so-called Great Daylight Comet, visible simultaneously in the sky. That was remarkable, and it became part of astronomical lore. The mid-1970s offered several comets within a short span, creating a brief sense of clustering. But never before have 7 distinct comets, each tracked and cataloged, each on independent orbits, converged so tightly in time. 2025 is different in scale and in kind. Statistical models tell us such clustering should be improbable. The orbits of comets are distributed across centuries and millennia, shaped by the slow perturbations of planets, the nudges of the Oort cloud, the gravitational tides of the galaxy. For seven to align so closely is akin to rolling dice again and again and watching them land on the same number each time. Possible? Yes. Likely? No. Some will point to the surveys themselves. Pan-STARRS, Atlas, and other modern instruments have dramatically increased discovery rates. We now see comets that previous generations would have missed. Perhaps the clustering is partly an illusion, a byproduct of vigilance rather than true rarity. But even accounting for improved detection, the numbers remain startling. More eyes on the sky explain faint comets like Atlas G3, but they do not explain why bright contenders like Pan-STARRS and Swan arrive in the same season. Solar maximum adds another layer of strangeness. The swarm reaches perihelion just as the sun enters its most active phase in decades. This guarantees drama in the skies, comet tails sculpted, severed, and reformed by turbulent winds and magnetic storms. For the casual observer, it will feel as though the comets are interacting with the sun in unique ways, their behavior exaggerated by timing. But coincidence alone cannot explain why so many are here to experience it together. This is why astronomers themselves have expressed surprise. The language of scientific papers is cautious, careful, measured. But between the lines lies astonishment. Even those who resist speculation acknowledge the odds are remarkable. Clustering happens, but rarely with this intensity. An interstellar visitor has arrived, but rarely with such uncanny timing. Together, they stretch coincidence close to its breaking point. For the public, the abnormality will be obvious. To step outside and see comet after comet, sometimes multiple at once, is an experience no living generation has had. It will feel orchestrated, even if the science insists otherwise. Children will grow up remembering 2025 as the year the sky filled with comets, a memory that will shape their sense of the cosmos for decades to come. And here lies the deeper truth. Rarity shapes meaning. If comets were common, they would lose their magic. But because they are not, because their arrivals are unpredictable and clustered only by chance, we cannot help but seek purpose. The abnormality of 2025 becomes a canvas for stories, for speculation, for wonder. For science, it is an opportunity. Rare events provide data that routine cannot. Multiple comets under the same solar conditions allow comparative studies of unprecedented scope. The presence of 3I Atlas adds the interstellar dimension, a chance to contrast native and alien chemistry. For once, the heavens have crowded the stage, and astronomers have front-row seats. For culture, it is a reminder. Normality is comfortable, but wonder thrives in the abnormal. When the sky breaks its usual rhythm, we look up, we ask questions, we imagine. In that sense, the swarm's strangeness is its greatest gift. It forces us out of routine, out of complacency, into curiosity. So let us be clear. This is not normal. 7 comets, 1 interstellar visitor, all arriving together, all under the restless gaze of a stormy sun. This is not what textbooks prepare us for. This is the sky reminding us that the universe does not owe us predictability. It owes us nothing, and yet it gives us wonder. The question now is how we will respond. With science, with stories, with fear, or with awe. The abnormality is undeniable. The meaning is ours to make. While the comets of 2025 are remarkable on their own, their timing intersects with another cosmic cycle that magnifies their story. The 11-year heartbeat of our sun. In 2025, the sun will reach its solar maximum, the peak of magnetic turbulence, a season when its face is littered with sunspots, when flares leap outward in arcs of fire, and when coronal mass ejections hurl billions of tons of plasma into interplanetary space. For comets venturing close to this restless star, the timing could not be more dramatic. At solar minimum, the sun is quiet. Its corona glows steadily, its surface shows only a handful of spots, its wind flows more uniformly. Comets in such years evolve in predictable ways. Their tails curve gently, their brightness rises smoothly, their comets expand without interruption. But solar maximum is different. It is chaos written in plasma and light. When comets pass through this storm, their behavior becomes unpredictable, sculpted by forces far stronger than their fragile nuclei can resist. Consider the ion tail, the long bluish streamer formed when ultraviolet radiation ionizes gases and the solar wind carries them outward. Under quiet conditions, ion tails flow steadily away from the sun. But under solar maximum, they become restless, whipped into kinks and folds, sometimes severed entirely. A coronal mass ejection can slice through a comet's tail like a cosmic blade, detaching it completely. For hours or days, the detached tail drifts in space like a ghost, while the comet begins to grow a new one. To observers on Earth, such events look almost supernatural, a celestial body bleeding light, then regenerating. Dust tails, too, respond to solar violence. Though governed mainly by radiation pressure rather than magnetic fields, they can still show disturbances when the solar wind surges. Under solar maximum, a comet's twin tails, ion and dust, may diverge dramatically, creating spectacular shapes that shift from night to night. For photographers and observers, the variations will be both frustrating and exhilarating. No two nights may look the same. For astronomers, these disturbances are not mere curiosities. They are data points, opportunities to measure how solar storms interact with fragile bodies. By observing multiple comets during solar maximum, scientists can compare responses across different compositions and sizes. The 2025 swarm, arriving just in time for peak activity, becomes a natural experiment, a chance to study solar-comet interactions on a scale never before possible. The implications extend to Earth as well. Solar maximum affects more than comets. It shakes our magnetosphere, disrupts satellites, confuses navigation systems, and paints auroras farther from the poles than usual. During powerful storms, communications may falter, power grids may strain, astronauts may seek shelter. In this way, humanity experiences solar maximum alongside the comets, sharing in the consequences of the sun's restlessness. The same storms that kink their tails ripple through our technologies. The symbolism is profound. While comets streak inward from the cold edges of the solar system, they meet the sun at its most fiery and unstable. The swarm does not arrive during calm, but during chaos. Their fragile ices, preserved for billions of years, will be tested under conditions as violent as the solar system can provide. Some may flare brilliantly, others may fragment, some may fade without warning. In every case, the sun will be both stage and sculptor, shaping their destinies with its storms. For culture, this timing adds weight to the spectacle. Ancient civilizations often linked comets to solar omens, imagining them as extensions of the sun's power. In 2025, that symbolism becomes literal. The comets will indeed dance to the sun's rhythm, their tails shaped by its winds, their brightness influenced by its energy. To those watching from Earth, it may feel like the sun itself is conducting the performance, a fiery maestro orchestrating a symphony of visitors. And then there is 3I Atlas, the interstellar stranger. Its behavior under solar maximum may be especially revealing. Composed of ices forged under another star, seasoned by interstellar radiation, it may carry volatiles unfamiliar to our system. How will those ices respond to the violence of solar storms? Will they vaporize earlier, flare brighter, fragment more easily? Each observation may carry hints of alien chemistry, glimpses of processes beyond our solar nursery. The fact that its passage coincides with solar maximum is, again, uncanny. Skeptics will remind us that solar maximums occur regularly, every 11 years. That one should coincide with a cometary swarm is perhaps no more remarkable than coincidence itself. And yet, for those inclined toward wonder, the timing feels too perfect. A rare gathering of comets, an interstellar visitor, and a stormy sun, all converging in the same year. Coincidence, yes, but coincidence of a kind that leaves us questioning. For scientists, the coming months will be filled with preparation. Instruments must be calibrated, campaigns coordinated, observations scheduled. The sun will be watched constantly, comets tracked nightly, data shared globally. The swarm and the sun together offer not just beauty, but an unparalleled opportunity for discovery. For the rest of us, the lesson is simpler. The universe does not perform on command, but when it does, the timing can be uncanny. In 2025, we will see fragile wanderers and a turbulent star meet in a spectacle of unpredictability. The sun at maximum, the comets at perihelion, chaos and fragility colliding in light. This is why the year is extraordinary, not only because 7 comets and a stranger arrive, but because they arrive when the sun itself is restless, painting the sky with storms. The stage could not be more dramatic. The performance could not be more profound. Human beings are creatures of pattern. We cannot help ourselves. When dots scatter across a page, we connect them into constellations. When events cluster in time, we string them into cause and effect. When chance produces something rare, we imagine a hand behind it. The year 2025, with its 7 comets, its interstellar stranger, its restless sun, presents the perfect canvas for this instinct. The question is not whether we will see patterns, but which ones we will choose to believe. The clustering of comets is by itself improbable. Probability theory insists that rare things do happen, and that improbable clusters are inevitable in long enough timelines. Mathematicians call it the law of truly large numbers. Given enough chances, even the strangest coincidences will occur. And yet, when the sky produces such a cluster, it does not feel random. It feels orchestrated, like a pattern waiting to be interpreted. History is filled with such interpretations. When Halley's Comet appeared in 1066 alongside the Norman Conquest, people insisted the two were linked. When 2 bright comets appeared in 1910, one of them, Halley again. Newspapers filled with speculation about plague and disaster. When Oumuamua swept past in 2017, its elongated shape inspired serious debate about alien technology. Each event became more than itself, transformed by the human need to weave pattern from chance. The swarm of 2025 will be no exception. 7 comets, an interstellar visitor, and solar maximum arriving together. It is too rich a tableau for the imagination to resist. Already speculation begins. Are these comets coordinated? Is 3i Atlas the conductor of the ensemble? Is the sun's turbulence part of a larger script? From science fiction writers to conspiracy theorists, the year will provide material irresistible for storytelling. But what does the evidence actually say? Astronomers trace the orbits backward, testing for hidden links. Each comet, it turns out, comes from a different path. Their histories diverge over centuries, their points of origin scattered across the vast Oort cloud. Some are long period, some short period, some freshly discovered. Their only connection is timing. Physics shows no hidden shepherd guiding them. 3i Atlas, too, tells its own story. Its hyperbolic trajectory is clear. It is not bound to the sun, not influenced by the planets in the same way as the others. It has come from elsewhere, and it will leave for elsewhere. Its presence overlaps with the swarm, but its orbit tells us it does not belong to them. The interstellar stranger is coincidence, not conductor. And yet, knowledge does not silence the pattern-seeking mind. Even when told the comets are independent, we still wonder. Even when data insists the stranger is unconnected, we still imagine. Our minds resist randomness. Coincidence feels unsatisfying. We want story, and story demands pattern. This is the paradox of the 2025 swarm. Scientifically, it is coincidence. Psychologically, it is connection. The comets are unrelated, yet we will weave them together. The stranger is independent, yet we will cast it as leader. The sun's maximum is cyclical, yet we will interpret its timing as meaningful. Science strips away the pattern, but culture restores it, each in its own way. This is not a failure of reason, it is part of being human. We evolved to seek meaning, to connect dots, to anticipate cause and effect. That instinct saved us from predators, guided us through seasons, and built civilizations. In the sky, it builds myths. It tells us comets are omens or fleets or messages. It tells us coincidences are conspiracies. It tells us that the universe is speaking even when it is silent. The challenge is balance, to embrace wonder without surrendering to delusion, to see the beauty of coincidence without mistaking it for design, to accept randomness without denying meaning. For meaning, after all, does not have to be cosmic, it can be human. The pattern we see in the swarm is not in the orbits of comets, but in ourselves. It is the reflection of our own need to belong to a story. Astronomy, at its best, acknowledges both sides. It presents the data, cold and clear. 7 comets, independent orbits, overlapping by chance. But it also embraces the wonder. The sky will be crowded, the view will be extraordinary, the moment will feel meaningful. The data strips away false connections, but the wonder remains, undiminished. So in 2025, when we look up and see tails stretching across the night, let us remember, the pattern is ours to make. We can see coincidence and still find meaning. We can accept randomness and still be amazed. The comets are not coordinated, but their timing still teaches us humility. Their independence does not diminish their beauty. The lack of connection does not erase the wonder of alignment. Perhaps in the end, the pattern we think we see is not in the sky at all. It is in us, our need to tell stories, to find order, to draw meaning from the vastness. The swarm is coincidence, but coincidence, when written across the stars, becomes something more. Among all the visitors of 2025, none carries a story as profound as 3I Atlas. The 7 comets of the swarm may astonish with their clustering, but they are, in the end, natives of our own solar system, fragments of ice and dust born in the Oort cloud or Kuiper belt, shaped by the gravity of planets and the breath of the sun. 3I Atlas is different. It is alien in the most literal sense, forged under the light of another star, carrying within it the chemistry of a system not our own. It is only the 3rd confirmed interstellar object humanity has ever detected. Oumuamua came first in 2017, its elongated shape and puzzling acceleration sparking debates that continue to this day. Then came 2I Borisov in 2019, a more conventional cometary visitor, but no less extraordinary for its foreign origin. And now, 3I Atlas, a traveler that has journeyed across millions of years and trillions of kilometers, slipping into our solar system on a one-time visit before vanishing again into interstellar space. Its orbit is unmistakable. Unlike the closed ellipses of native comets which loop endlessly around the sun, 3I Atlas traces a hyperbolic path, an open curve that testifies to its foreign birth. It arrives at tremendous speed, faster than the sun's gravity can capture, dives inward, and then departs forever. No cycle, no return, no second chance. For astronomers, this fleeting presence is a gift, a rare opportunity to study matter born in a different cradle of creation. What makes it even more remarkable is the timing. To have an interstellar visitor appear during the very year when 7 comets crowd our skies stretches coincidence to its breaking point. Astronomers insist the alignment is chance, that probability allows for such clustering. But to the human mind, the overlap feels uncanny. The swarm is already abnormal. The addition of a stranger from beyond makes it feel almost deliberate, as though the universe itself is trying to draw our attention. The questions multiply. What can 3I Atlas tell us about the conditions in its home system? What kinds of ices survived its long journey through interstellar darkness? Will its activity near the sun mirror that of our comets, or will it reveal exotic chemistry unknown to our skies? Its spectrum may carry answers, faint lines of light that whisper stories of alien worlds. Every observation becomes a clue, every measurement a fragment of a tale written beyond our star. Yet the stranger is fragile. Comets, whether native or alien, are delicate bodies, prone to outbursts, fragmentation, even disintegration. Oumuamua surprised by showing no visible coma, leaving its nature uncertain. Borisov displayed more traditional activity but broke apart under solar stress. 3I Atlas could do either, or something altogether new. Its fate is unknown, and that uncertainty heightens the drama of its visit. For astronomers, the arrival has triggered a race. Observatories around the world and in orbit are already planning coordinated campaigns. Telescopes will track its brightness, measure its tail, capture spectra of its gases. Amateurs, too, will contribute, filling in gaps, sharing images, building a global record of its passage. Every night matters. Every hour may bring new revelations, or mark the last chance before it fades into the void. For culture, the interstellar visitor touches something deeper. It is a messenger from beyond, proof that our solar system is not isolated. Fragments from other stars drift into our skies, reminding us that we are part of a galaxy alive with motion. Some will see it as omen, others as opportunity, still others as mystery. In every interpretation, it becomes more than ice and dust. It becomes symbol. Speculation, of course, will flourish. Some will suggest coordination, imagining 3I Atlas as conductor of the comet swarm, an alien emissary guiding a celestial chorus. Others will see warning, a cosmic sign layered atop earthly anxieties. The rational explanation, coincidence, will convince scientists, but not silence imaginations. The presence of an interstellar object during a swarm, this rare, is too tempting, too perfect for the human mind to leave unembellished. And perhaps that is fitting. 3I Atlas is, after all, an embodiment of the unknown. It comes from beyond our maps, beyond our models, beyond our history. It does not belong here, yet for a moment it is part of our story. To see it, to measure it, To imagine its origins is to brush against the wider galaxy, to sense the immensity beyond our star. The interstellar stranger will not stay. Its orbit guarantees departure, its speed ensures no return. But while it is here, it offers perspective. We are not alone in being wanderers. The galaxy is filled with fragments adrift, stories untold, travelers unseen. 3I Atlas happens to cross our sky in 2025, and in doing so, it reminds us that the universe is vast, unpredictable, and filled with encounters we cannot anticipate. The swarm alone would have been extraordinary. The stranger alone would have been historic. Together, they become something more. A mystery layered on a mystery, coincidence piled upon coincidence, a story that demands attention. 3I Atlas has appeared, and with it, the questions multiply. Coincidence or connection? Chance or meaning? Science will measure, culture will interpret, and in between, wonder will thrive. Every comet's orbit is a fingerprint, a trail carved through space by gravity's patient hand. It tells us where the comet has been, where it is going, and whether it belongs to our solar family or comes from beyond. In the case of 3I Atlas, that fingerprint is unlike almost anything we have seen before. A hyperbolic path, flung open like a door to the stars, marking it forever as an interstellar visitor. And in the context of the 2025 swarm, its orbit has become not only a map, but a mystery. Most comets travel on ellipses. Some are short period, looping back every few years or decades. Others are long period, taking millennia to return, their aphelia lost in the vastness of the Oort cloud. But all are bound. The sun's gravity holds them, no matter how elongated their paths may be. 3I Atlas breaks that rule. Its velocity is too great, its trajectory too wide. Even after the sun bends its course, it will not be captured. It will enter, pass, and depart, never to return. Its orbit is a signature of foreign birth, proof that it is not ours. When astronomers first calculated that orbit, the evidence was unmistakable. The eccentricity, a measure of how stretched the orbit is, was greater than 1. That single number told the story. This comet came from interstellar space. Its speed, even after accounting for gravitational interactions, exceeds the solar system's escape velocity. Like Oumuamua and Tia Borisov before it, 3I Atlas is a traveler from another sun. Its inclination adds intrigue. Unlike some interstellar objects that plunge steeply relative to the ecliptic, 3I Atlas travels at a modest angle, weaving through the same plane where planets and comets reside. This geometry places it in proximity, close enough that, during its passage, it crosses orbital regions not far from where the 7 native comets will be. No collision is possible, but the closeness of the alignment has fueled speculation. To human eyes, it feels as though the stranger has joined the swarm intentionally, its orbit angled to meet theirs in a kind of cosmic rendezvous. Its retrograde motion adds another layer. Most of the solar system moves in the same direction, orbiting the sun like dancers circling a stage. 3I Atlas comes the other way, racing against the flow. To astronomers, this is no surprise. Interstellar visitors arrive from every direction, unconstrained by the choreography of our planets. But visually, conceptually, it heightens the drama. The stranger cuts across the grain, a disruptive presence moving contrary to all we know. The nodes of its orbit, points where it crosses the ecliptic, are of particular interest. These are the places where, geometrically, it comes closest to sharing space with the comets of the swarm. If any interaction were possible, however subtle, it would occur near these nodes. Astronomers calculate the dates with precision, noting when 3I Atlas will pass those invisible intersections. If other comets flare or fragment at the same time, suspicion will grow. But so far, no evidence demands that conclusion. Still, coincidences provoke questions. Could gravity from the interstellar visitor influence the others? The answer, in terms of physics, is almost certainly no. Its mass is tiny compared to the sun or even the planets. Its passage is swift, too brief to tug significantly at neighbors. Any measurable perturbation would be vanishingly small. Yet the timing, the overlap with the swarm, makes the question linger. For scientists, the intrigue lies in measurement. By tracking its path with exquisite accuracy, astronomers can refine models of its origin. Which star system did it come from? How long has it drifted? Could it be part of a stream of interstellar debris, fragments from a planetary system disrupted long ago? Its orbit is not just a curiosity. It is a breadcrumb trail across the galaxy. Each calculation brings us closer to understanding the environments where other stars give birth to comets. For culture, the intrigue lies in symbolism. A comet from another star, arriving just as 7 native comets crowd our skies, feels less like chance and more like story. It invites interpretations of guidance, of leadership, of hidden orchestration. Even if the mathematics denies connection, the narrative is irresistible. The orbit becomes not just a line on a chart, but a thread in a tale woven by human imagination. And perhaps that is fitting. Orbits are, after all, stories written in motion. They record encounters, influences, histories invisible to the naked eye. Every curve, every tilt, every inclination tells of forces that shape the traveler across vast spans of time. For 3I Atlas, the story is one of exile and journey, of a fragment cast loose from another system, wandering across interstellar night until fate carried it here. In 2025, that orbit intersects with ours, not physically, but in meaning. For a brief season, its path crosses our sky, entangling with the comets of our swarm, sparking questions that stretch beyond science. Coincidence or connection, randomness or orchestration, the orbit itself does not answer. It only carries the stranger forward, inexorable, precise, indifferent. Yet for us, watching from Earth, the intrigue remains. Because in that arc drawn across the heavens, we glimpse not only the mathematics of gravity, but the mystery of chance. And in that mystery, wonder thrives. For every comet, there comes a reckoning. After eons of drifting in darkness, after years of slow approach, there is a single moment when destiny arrives, the instant of perihelion. It is here, at closest approach to the sun, that comets reveal their true character. Some flare with brilliance, dazzling the world. Others crumble, their fragile nuclei overwhelmed by heat and tidal stress. Perihelion is the moment of truth, and in 2025, it will be the stage where the swarm and the interstellar stranger among them face their trials. The physics are simple, yet their consequences are dramatic. As a comet nears the sun, the intensity of radiation rises exponentially. Ice that has been locked solid for billions of years begins to vaporize. Subsurface reservoirs of carbon monoxide, carbon dioxide, and methane erupt, driving outbursts that hurl jets of gas and dust into space. The coma swells, tails lengthen, brightness surges. What was once a faint smudge becomes a beacon, visible even to the naked eye. But perihelion is merciless. Heat fractures surfaces, outgassing destabilizes rotation. Nuclei, often no more than loosely bound rubble piles, can split apart entirely. For some comets, perihelion is a death sentence, their bodies fragmenting into clouds of dust that quickly disperse. For others, it is a transformation, a chance to display grandeur before retreating once more into the cold. The uncertainty makes perihelion the most thrilling and the most dangerous moment in a comet's journey. For the 2025 swarm, perihelion carries particular weight. With 7 comets arriving in such close sequence, each will face the sun's fire within weeks of the others. Their responses will be recorded side by side, offering comparisons science rarely enjoys. Pan-stars may blaze into naked-eye glory. Swan may reveal its hydrogen-driven activity on a grand scale. Stereo may perish outright, consumed in the solar corona. Atlas K1 may flare or fade. Atlas G3 may whisper faintly. Lemon and Neat may linger quietly. Each perihelion is an experiment, and together they form a dataset of extraordinary richness. And then there is 3I Atlas, the interstellar visitor. Its perihelion will be watched with unmatched intensity. Born under another sun, its ices are alien, its chemistry untested in our skies. Will it behave like our comets, or will it surprise us with unusual outgassing? Could it carry volatiles unknown in our solar system, igniting activity earlier, brighter, or stranger than expected? Every flare, every jet, every change in brightness may hold clues about its origins. Its perihelion is not just the climax of its journey here, it is a once-in-a-lifetime laboratory for interstellar science. For observers on Earth, perihelion brings both spectacle and challenge. Some comets will brighten into visibility, their tails stretching across constellations. Others will be lost in the sun's glare, observable only by spacecraft instruments designed to stare directly at our star. Images from SOHO, Stereo, and the Solar Dynamics Observatory may capture their closest approaches, showing comets as tiny sparks skimming the solar corona before vanishing. In those images, the drama of survival or destruction unfolds silently, a celestial drama watched from afar. Perihelion is also the moment when coincidences may seem most meaningful. If multiple comets flare or fragment at the same time, imaginations will race. Is it mere chance or coordination? Are they responding independently to the same solar conditions, or is there a hidden connection? Rationally, solar heat explains all, but the clustering of events during solar maximum, combined with the presence of an interstellar stranger, will tempt many to see more. The sun itself adds layers of unpredictability. During solar maximum, ultraviolet radiation is stronger, solar wind more turbulent, coronal mass ejections more frequent. Comets at perihelion during such times may experience sudden tail disconnections, brightness surges, or complete disintegration. These effects are natural, but they will look extraordinary, feeding the sense of drama. For astronomers, this is a rare chance to study interactions between comets and solar storms in real time across multiple bodies. Culturally, perihelion embodies the archetype of trial by fire. Every comet must face it, and not all survive. In myth, heroes enter ordeals and emerge transformed or perish in the attempt. Comets mirror this mythic arc. They plunge inward, risk destruction, and emerge changed. In 2025, millions of people may watch these trials unfold, some with telescopes, others through images shared online, all participating in a story as old as the heavens. Speculation will swirl. If 3i Atlas displays unusual behavior at perihelion, strange jets, unexpected fragmentation, odd chemistry, interpretations will multiply. Some will declare it proof of alien origin. Others will see it as signal, as omen, as part of the supposed pattern tying the swarm together. Science will caution patience, reminding us that perihelion is unpredictable for all comets, native or alien. But the narrative will already be alive, carried by human imagination. Yet beyond speculation lies a deeper truth. Perihelion strips comets down to their essence. It reveals their structure, their chemistry, their fragility. It shows us not only what they are, but what they have endured. To witness it is to see billions of years of history distilled into a single moment of light. For the 2025 swarm, perihelion is not just an astronomical milestone. It is the crucible in which the year's mysteries will be tested. Will the comets survive? Will they dazzle or disappoint? Will the stranger reveal secrets of another star? The answers lie in the fire of the sun, waiting for the moment of truth. As if 7 comets and an interstellar visitor were not enough, the stage of 2025 adds yet another element of drama. The sun itself, entering its most turbulent season in over a decade. Solar maximum is no gentle backdrop. It is a storm, a furnace alive with magnetic tempests, a conductor whose baton is made of plasma and light. For comets approaching perihelion in such a season, the sun's fury is not an abstract idea. It is a force that will shape their very appearance, transforming their tails into banners of chaos. The sun at maximum is restless. Dark sunspots bloom across its face, each one a wound in its magnetic skin. Flares leap upward, arcs of fire taller than Earth itself. Coronal mass ejections hurl billions of tons of charged particles into the void, racing outward at millions of kilometers per hour. When such storms reach Earth, they rattle our magnetosphere, spark auroras, and threaten our satellites. But comets, fragile and exposed, feel the brunt of those storms even more vividly. The ion tails of comets are delicate threads of plasma, formed when solar ultraviolet light strips electrons from gas molecules, and the solar wind carries them outward. Under calm conditions, they stream straight and elegant, pointing directly away from the sun. But in solar maximum, the wind does not blow steadily. It gusts, it twists, it surges. Ion tails kink, ripple, and sometimes sever completely. To observers on Earth, it looks as though the comet has been wounded, its tail torn away by an unseen hand. The old tail drifts ghost-like into the void while a new one grows behind it, proof of resilience in the face of chaos. Dust tails, heavier and less responsive to magnetic fields, also feel the sun's moods. Radiation pressure bends them gently, but when solar storms strike, the boundary between dust and ion tails can blur, creating strange shapes, forked streams, arcs that curve unnaturally, structures that seem alive. For photographers, 2025 will be a feast, every comet a canvas of shifting geometry painted by solar winds. For astronomers, this fury is opportunity. By studying how comets respond to specific solar events, scientists can learn not only about the comets themselves, but also about the dynamics of the solar wind. Each disconnection event, each sudden twist in a tail, becomes a tracer of invisible forces. With 7 comets active at once, comparisons can be made across different sizes, compositions, and distances, offering a natural experiment that no laboratory could ever replicate. But for culture, the sun's fury carries symbolism. To ancient eyes, a comet was already an omen. To see its tail severed, its form distorted, would have seemed like divine intervention, a punishment or a warning. In 2025, the effect will be understood in terms of plasma physics, yet the emotional response will be no less strong. The sky will look alive, the comets like dancers tossed by a storm they cannot resist. The sense of choreography, of pattern, will feel irresistible, even if science insists on randomness. This is where speculation thrives. If multiple comets display disturbances at once, tails snapping, brightness surging, people will wonder, are they connected? Are they responding to each other? Or are they responding to something else, something hidden? The rational explanation is simple: solar storms striking them simultaneously. But the timing, the spectacle, the uncanny overlap with the swarm and the stranger will tempt many to imagine deeper forces. 3I Atlas will be especially scrutinized. As an interstellar visitor, its chemistry may cause it to respond differently to solar storms. Perhaps its ices will vaporize more readily, its tail more easily disrupted. Or perhaps it will prove unusually resilient, its alien structure withstanding the chaos better than native comets. Whatever happens, observers will compare its behavior to that of the swarm, looking for anomalies, searching for signs of difference or connection. For Earth, too, the sun's fury will not go unnoticed. Solar maximum guarantees auroras spreading farther toward the equator than usual, shimmering curtains of green and red visible in skies where they are rarely seen. At the same time, satellites may falter, jeeps may drift, communications may stutter. If these events coincide with cometary disturbances, imaginations will conflate them, weaving them into a single narrative. The comets will become symbols of the sun's anger, even if they are merely fellow travelers enduring its storms. In truth, the connection is not mystical but mechanical. Solar storms strike outward in all directions. Comets and Earth alike are caught in their path. The shared disturbances are not evidence of coordination but of common exposure. Yet for those watching from Earth, the distinction may blur. Seeing comets twist above while auroras ripple overhead, people will feel part of a single performance, a cosmic drama choreographed by the sun. This is why the swarm's timing is so extraordinary. Had these comets arrived during solar minimum, their tails would have streamed quietly, their behavior predictable, their story less compelling. Instead, they arrive in a stormy season when every passage may bring surprises. Their beauty will be magnified, their mysteries deepened, their stories enriched by the violence of the star they orbit. So what will we see in 2025? Perhaps pan-stars with a tail severed by a solar gust, Swan's vast hydrogen envelope flickering under ultraviolet assault, Stereo vanishing in the corona, its death masked by a solar flare, Atlas K1 and G3 struggling faintly against turbulence, Lemon and Neat displaying subtle disconnections, and 3I Atlas, the alien, responding in ways that defy prediction, each a note in a symphony, conducted by the sun's fury. The comets may not be connected to each other, but they are all connected to the sun. And in 2025, that connection will be revealed in light, in plasma, in tails twisting and breaking under forces too vast to control. The swarm's mystery may remain unsolved, but its beauty will be undeniable, shaped, sculpted, and magnified by the fury of the star that rules them all. The comets of 2025 may streak across the heavens, but their true stage is larger than the sky. Their presence coincides with a sun at maximum fury, and the storms that sculpt their tails do not stop at the edge of interplanetary space. They continue onward, washing against Earth, shaping our lives in ways we often forget until disruption arrives. These are the echoes of the swarm, reverberating not only through telescopes, but through our technologies, our skies, and our imaginations. When charged particles from coronal mass ejections slam into Earth's magnetic shield, the planet responds like a drum struck by a cosmic mallet. The magnetosphere shudders, currents ripple through the upper atmosphere, and geomagnetic storms surge into existence. These storms can induce electrical currents in the long wires of power grids, strong enough to overload transformers and plunge entire regions into darkness. In March 1989, one such storm left Quebec without power for 9 hours, a reminder that our modern world, for all its sophistication, still bows to solar weather. Satellites, too, are vulnerable. High-energy particles can penetrate shielding, scrambling electronics, and corrupting memory. Communications flicker, GPS signals drift, weather monitoring falters. In extreme cases, satellites are lost entirely, their circuits burned beyond repair. During solar maximum, such risks multiply, and in 2025, every surge of activity that twists a comet's tail will also brush against the fragile infrastructure circling Earth. Aviation feels the effects as well. Near the poles, where Earth's magnetic protection is weakest, radiation levels rise during storms. Airlines sometimes reroute flights to avoid exposing passengers and crew to elevated doses, while also protecting aircraft systems from interference. Each adjustment is a reminder that space weather is not a distant phenomenon. It shapes schedules, alters routes, and enters daily life in quiet, unseen ways. To the casual observer, these disruptions may appear linked to the comets themselves. If a power grid fails while a bright tail flares in the night sky, the human mind cannot resist connection. The comets become symbols of disturbance, their presence woven into narratives of disruption. Rationally, we know it is the sunstorms that cause both, striking comets and Earth alike. But emotionally, the pattern is irresistible. Visitors arrive and the world trembles. History shows the persistence of such associations. Medieval chronicles recorded plagues, wars, and famines alongside comet appearances, convinced they were linked. In truth, both were often coincidental, connected only by timing. In 2025, the same psychological pattern will reappear, magnified by social media's reach. A blackout here, a satellite failure there, and the swarm will be drawn into conversations not only of wonder, but of fear. Yet in those echoes lies opportunity. Scientists today can trace effects precisely, matching disturbances in Earth systems to specific solar flares and ejections. Magnetometers monitor the planet's field. Spacecraft watch the sun's surface constantly. When comets flare or tails disconnect, the cause can be matched to solar data with clarity unthinkable in earlier centuries. Where our ancestors saw omens, we see physics. Where they imagined doom, we recognize patterns of plasma and magnetism. Still, the emotional impact remains. Auroras are the most visible echo, painting the sky with green and red curtains as particles stream along Earth's magnetic field lines. During solar maximum, auroras spread farther from the poles, appearing over cities unaccustomed to their glow. In 2025, people who have never seen the northern or southern lights may step outside to find the heavens alive with color, auroras above, comets streaking across the stars beyond. For many, it will feel like a sky transformed, a message written in light. The symbolism will not be lost. Comets ignited by solar storms, auroras ignited by the same events, human technology flickering under the same pressure. It all feels like choreography. Even when science explains the connections, the sense of narrative remains. The swarm is not simply in the sky, it is in our world, touching us through the echoes of the sun's fury. Speculation will seize on these coincidences. A geomagnetic storm knocking out power may be attributed to the interstellar stranger. A satellite glitch may be blamed on the swarm. Even when experts clarify, the stories will persist, fueled by the need to find meaning. The echoes on Earth will become part of the swarm's mythology, joining the celestial spectacle with terrestrial consequence. But there's another lesson hidden in those echoes. They remind us that we are part of the same system as the comets. We orbit the same sun, feel the same storms, live under the same magnetic shield. The disturbances that twist their tails are the same disturbances that ripple through our power lines. The connection is not mystical. It is physical, shared. In watching them, we are watching ourselves. For scientists, the echoes are valuable data. Studying how solar storms affect comets and Earth simultaneously provides insights into both. For culture, they are stories, binding sky and ground together. For all of us, they are reminders of fragility. Our technologies, our flights, our comforts, all depend on a quiet sun. And when the sun is not quiet, we are reminded how much larger the universe is than our control. The comets will not strike Earth. They pose no physical threat, but through the echoes of solar storms, their presence will be felt here all the same. In auroras and outages, in rerouted flights and flickering screens, in myths old and new. The swarm may live in the heavens, but its resonance will reach our lives, carried by the echoes of Earth. For as long as humanity has looked upward, comets have carried an aura of transformation. They were not steady lights like the stars, nor regular wanderers like the planets. They appeared suddenly, without warning, blazing across the heavens before fading again into the dark. To ancient cultures, this unpredictability marked them as messengers, harbingers of change. Kings fell, empires wavered, plagues swept through cities, and in the sky a comet burned. Coincidence became prophecy. The heavens seemed to whisper that nothing would remain the same. In 2025, the same symbolism will inevitably return. 7 comets arriving together, joined by a stranger from beyond the stars, will be interpreted not only as astronomical coincidence, but as cosmic commentary. Some will see them as omens of upheaval, others as signs of renewal, still others as portents of disaster. Social media will amplify every theory, every speculation, weaving myth as rapidly as telescopes gather data. The swarm will become not only a spectacle of light, but a canvas for human imagination. Science tells us that comets are not messengers, only fragments of ice and dust obeying the laws of gravity. They bring no plagues, no wars, no blessings, yet their timing often intersects with human history in ways that feel uncanny. In 44 BCE, a bright comet appeared after the assassination of Julius Caesar, interpreted as the dictator's soul ascending. In 1066, Halley's comet blazed above England as armies clashed at Hastings. In 1910, Halley returned amid fears of poison gas in its tail, just as the world edged toward war. Comets may be innocent, but we drape them in meaning. The year 2025 will offer fertile ground for such interpretations. The world, already restless with uncertainty, will see the sky filled with visitors and ask, why now? Why so many? Why alongside an interstellar stranger in a turbulent sun? Rational explanations will not silence symbolic ones. Harbingers do not need to be real to be believed. They need only to appear at the right time. Yet not all change must be feared. In some traditions, comets were not omens of doom, but heralds of renewal. The sweeping of the sky by a luminous tail could be seen as cleansing, as preparation for rebirth. In this view, comets symbolize cycles, endings that make way for beginnings. In 2025, as the swarm blazes, some will adopt this interpretation. They will see the heavens not warning of collapse, but promising transformation. There is also a deeper, quieter truth. Comets themselves are agents of change, though not in the ways myths once imagined. In Earth's early history, they may have delivered water, seeding oceans. They may have brought organic molecules, nudging chemistry toward life. Each time a comet approaches, it sheds dust that becomes meteor showers, altering the texture of our skies. Their impacts, rare but real, have reshaped planets. In this sense, comets are indeed harbingers of geological and biological change written across deep time. 3. I Atlas adds another layer to this symbolism. As an interstellar visitor, it carries chemistry from another system. In its ices may lie molecules forged under the light of a different star. If comets are carriers of change, then this stranger is a carrier of difference, an ambassador of the galaxy, whispering of worlds we cannot see. Its presence in 2025 will remind us that Earth is not isolated, that change can come from beyond, that the universe is larger than our histories. The sun's fury reinforces the theme. Solar maximum is itself a cycle of change, a reminder that even the star we rely on is restless. In the same year that comets fill the sky, the sun will paint auroras across unfamiliar latitudes, disrupt satellites, and shake our technologies. For those inclined toward symbolism, the timing will seem perfect. Change above, change below. Harbingers everywhere. Harbingers. But perhaps the deepest change will be internal. To witness 7 comets in an interstellar stranger in 1 year is to be reminded of scale. Our lives, our histories, our struggles may feel vast to us, but they unfold beneath a sky alive with forces beyond our control. Comets remind us of fragility, of impermanence, of the inevitability of transformation. To look up in 2025 may not tell us what will happen, but it will tell us that nothing, no empire, no age, no certainty, lasts forever. For scientists, the harbingers are opportunities, chances to study cometary chemistry, solar storms, interstellar matter. For culture, they are symbols, signs to interpret, stories to tell. For humanity as a whole, they are reminders. Change is not coming, it is constant. The comets do not bring it, they reveal it. And so, when the swarm arrives, we may call them harbingers of change, not because they dictate our fate, but because they reflect it. Not because they foretell collapse, but because they mirror the truth we already live, that change is inevitable, and that to exist is to be transformed. Every story has its climax, but every comet has its farewell. The brilliance of perihelion, the drama of solar storms, the speculation of patterns, all of it fades as the orbits carry these icy travelers outward again. In the months after 2025's extraordinary swarm, the sky will slowly empty. The tails will shorten, the comet will shrink, and one by one the comets will slip back into the darkness that is their true home. The swarm will disperse, leaving behind memory, data, and silence. This is the rhythm of comets. Their lives as visible wonders are brief. For years, for centuries, even for millennia, they drift invisibly at the edges of the solar system. Then, for a few precious weeks, they blaze in the sun's light, their beauty impossible to ignore. And then, inevitably, they fade. What dazzled in May is gone by July. What filled newspapers in September is forgotten by December. Their departures are reminders of impermanence, of the fleeting nature of wonder. In 2025, those departures will come in sequence. Pan-STARRS, the bright contender, may linger longest, its tail stretching faintly into autumn skies before vanishing. SWAN will fade as its hydrogen envelope disperses into interplanetary space. Stereo, the suicide diver, may not even survive to depart, its fragments scattered invisibly into the solar corona. Atlas K1 and G3 will slip quietly into obscurity, their faint trails noticed only by dedicated telescopes. Lemon and Neat, too modest for the naked eye, will leave almost unnoticed. And then finally, the interstellar stranger. 3I Atlas will arc outward on its hyperbolic path, accelerating away from the sun, away from the planets, away from us. It will not return. Its departure is permanent, a one-time crossing written into its orbit. By 2026, it will be gone, another speck of interstellar debris drifting into the dark between stars. Humanity will never see it again. The data gathered in those brief months will be all we ever know of it. For astronomers, the departures mark the end of an extraordinary observing campaign. Telescopes will have tracked brightness curves, measured spectra, imaged tails, and recorded every detail. The analysis will continue for years, long after the comets themselves have vanished. Papers will be written, theories tested, models refined. The swarm will live on in science, its legacy not in the light it shed, but in the knowledge it left behind. For culture, the departures will be bittersweet. The sky that seemed so alive will return to its usual rhythm. Stars steady, planets predictable, no streaks of ice igniting in the night. Those who looked up will remember, but memory fades quickly. Just as earlier generations forgot the comets that once shook them, so too will 2025 pass into history. Perhaps it will be remembered in myths, or perhaps only in archives. The brilliance of the swarm will belong to those who saw it. Yet even in departure, the comets teach. They remind us that beauty is fleeting, that wonder is temporary, that everything we cherish eventually passes. Their fading is not tragedy, it is truth. The universe is not static, it is motion, change, departure. To love comets is to accept their impermanence, to treasure their light precisely because it does not last. Speculation will not fade so easily. Some will insist the timing of the departures holds meaning, that the simultaneous vanishings prove connection. Others will claim that 3I Atlas, departing forever, carried with it a message or a warning. Even as science closes the book, imagination will keep writing. The swarm will live not only in data, but in stories told by those who refuse to let it go. And perhaps that is fitting. The comets themselves may leave, but their impact remains. They will linger in photographs, in the memories of children who saw them, in the auroras that lit the skies beneath their passage. They will linger in myths reborn, in conspiracies whispered, in symbols reinterpreted. Departure is not erasure, it is transformation. The comets will cease to shine above us, but they will continue to shine within us. The interstellar stranger's farewell carries particular poignancy. Its departure is final, irreversible. Unlike the others, it will not circle back in centuries or millennia. 3I Atlas came once and once only. To witness it is to witness uniqueness, a moment that will never repeat. Its loss reminds us of the vastness of the galaxy, of all the travelers that pass unseen, of all the wonders we never notice. It leaves us with humility, the recognition that we are fortunate to have seen it all. In the end, the final departures of 2025 are not endings, but transitions. The comets return to darkness, but the memory of their light remains. The data remains. The stories remain. The wonder remains. That is their gift, not to stay, but to pass, and in passing to remind us how precious a fleeting moment can be. The sky will grow quiet again, but for those who watched, it will never be the same. When the skies of 2025 finally grow quiet, when the comets have faded, and the interstellar stranger has slipped back into the dark, what remains? The spectacle will be gone, the tails no longer visible, the auroras subdued as the sun moves past its maximum. The world will return to its routines, and yet the legacy of the swarm will endure, etched into memory, into science, into story. For astronomers, the legacy is clear. The swarm provided an unprecedented opportunity. 7 comets observed in the same season, each tested under the same solar conditions, each compared against the others. Data collected in 2025 will enrich cometary science for decades, sharpening our understanding of volatile chemistry, tail dynamics, fragmentation, and interactions with solar storms. The interstellar visitor, 3I Atlas, will stand apart as a singular case, a chance to study matter forged under another star. Its spectra, its jets, its orbit will be analyzed again and again, each detail mined for clues about other planetary systems. The swarm will fade, but the science will remain. For culture, the legacy is more elusive, but no less profound. Millions will remember 2025 as the year the sky came alive. Some will recall stepping outside and seeing a comet for the first time in their lives. Others will remember the photographs shared online, the videos of multiple tails streaking across the heavens, the discussions of omens and mysteries. Myths will be reborn in modern language, on forums, in books, in whispered conversations. For many, the swarm will mark the moment they first truly looked up. The comets themselves will linger in symbols. Pan-stars as the bright contender, Swan as the hydrogen whisperer, Stereo as the tragic diver, Atlas K1 as the lesson in humility, Atlas G3 as the survey's quiet child, Lemon and Neat as the steady companions, and 3I Atlas as the alien messenger. Each will take on archetypal roles in the story we tell about 2025. The swarm will not only be remembered as an astronomical event, it will be remembered as a narrative, a cast of characters who played out a cosmic drama. Speculation will endure as part of the legacy. No matter how carefully science explains coincidence, the timing of the swarm and the stranger will continue to provoke questions. Was it chance? Was it pattern? Was there something more? For some, the swarm will always be a mystery, a moment when the universe seemed to be speaking in riddles. And in a sense, that speculation is itself part of the gift. Wonder thrives not only in answers, but in questions that refuse to fade. The legacy also lies in humility. To watch comets blaze and fade is to be reminded of impermanence. Their beauty is fleeting, their visits rare, their departures final. The swarm teaches that nothing lasts, that even the brightest lights vanish into darkness. Yet it also teaches that impermanence does not erase meaning. On the contrary, it creates it. The memory of what passes is often more powerful than the permanence of what remains. On Earth, the legacy may also include resilience. The same solar storms that sculpted cometary tails tested our technologies, disrupted our systems, and painted our skies with auroras. The echoes of the swarm were not only visual, but practical. Power grids strained, satellites faltered, flights rerouted. Humanity was reminded once again of its dependence on a star that does not always shine gently. The swarm's legacy in this sense will include new awareness of our vulnerability and perhaps new determination to prepare. But beyond science, beyond culture, beyond systems, the legacy of the swarm is wonder. For a brief season, the sky told a story that none of us had expected. It was not written for us, not orchestrated by design, not meant as message. And yet, we found meaning in it. We looked up and saw beauty, fragility, coincidence, and mystery woven together. We felt small, but connected. We felt fleeting, but part of something vast. That feeling of wonder in the face of the cosmos is the true gift the swarm leaves behind. In centuries to come, when future astronomers look back, they will see Tuntum recorded in archives, in orbital plots, in data tables. But they will also find stories, accounts of the year when 7 comets and a stranger from beyond filled the sky. They will see how humanity responded, how we measured, how we speculated, how we dreamed. And they will know that the legacy of the swarm was not only in science, but in spirit. For now, as the comets depart and the heavens grow still, we carry that legacy with us. The swarm has ended, but the wonder endures. The universe has reminded us that even in randomness, beauty flourishes, that even in coincidence, meaning is found, that even in fleeting light, memory lasts. And perhaps that is the final truth of 2025, that the legacy of the swarm is not in the comets themselves, but in us, in the way we looked up, in the way we felt, in the way we remembered. The comets are gone, but the story remains.